Yeah, namaste. In continuation to previous class, this is the concept of de-arrangement. De-arrangement of things. You know the arrangement. What should be the de-arrangement? I took an example in the previous session. Here also, you can take one more example like this. You have some 5 different colored boxes. 5 different colored boxes. And 5 different colored balls. The colors of these balls are same as that of boxes. Then you have to place these balls in the boxes in such a way that the balls must go in the corresponding colored boxes. For example, if you have a green box and a green ball must go into green box. If you have blue box and blue ball must go into blue box. If you have white box and white ball must go into white box. If you have blue, some other colors, what I mean to say, like that, if the balls are placed in their corresponding colored boxes, that is nothing but the arrangement. If no ball is placed in their corresponding colored boxes, they are said to be the de-arrangement. So, if I take an example, then you will better understand this. Let me give an example first so that you will become more comfortable. Like this. If you take 3 envelopes and 3 letters, I repeat, let us take 3 envelopes and 3 letters. 3 envelopes and 3 letters, they are all addressed envelopes. They are all addressed envelopes. So, let me take E1 first envelope and E2 second envelope and E3 third envelope. L1 first letter, L2 second letter, L3 third letter. So, if they are placed in their corresponding envelopes, that is a right arrangement. The right arrangement will always be one only. 3 envelopes, 4 letters, 4 envelopes, 4 letters, or 5 envelopes, 5 letters, or 100 envelopes, 100 letters. The arrangement, correct arrangement will always be 1. Okay. Now, let us start with that one like this. So, E1 L1. E1 L1 is the right arrangement, and next E2 L2 is the right arrangement, and E3 L3 is also right arrangement. So, in this case, all are correct. No doubt in this one. All are placed in their right envelopes. Unlike this, E1 L1, next E2 L3, E3 L2. Similarly, E2 L2, envelope 2 is containing the right letter. Envelope 1 placed with letter 3. Envelope 3, letter 1. In this one, only 1 is correct. Similarly, E3 L3, E2 L1, E1 L2. Just if you observe this carefully, E1 L1 correct, E2 L2 correct, E3 L3 correct. That means in the second, third and fourth arrangements, you have only 1 letter placed in the right envelope. Rest all are wrong. Now, let us try for others like E1 L3, E2 L1, E3 L2. If you observe properly, no letter is placed in the right envelope. Understand that. That is nothing but the de-arrangement. No letter is placed in the right envelope. Need not be like this. E1 L2, E2 L3, E3L1. Just observe this carefully. This is nothing but de-arrangement. So what is a de-arrangement here? No letter is placed in the right envelope is nothing but the de-arrangement. So if you have 3 envelopes, 3 letters, in fact, these 3 envelopes in 3 letters, these 3 letters in 3 envelopes can be placed in 3 factorial different ways. This 3 factorial is nothing but 6. These are 6. 1, 2, 3, 4, 5, 6. 6 different arrangements we have got. Among these 6 different arrangements, you can observe that all correct case is only 1. This is all correct case. In this 3, only 1 correct. This is only 1 correct. In this one, no one is correct. So no one is correct is nothing but the de-arrangement. Understand that. Understand that, please. So now de-arrangement means if some objects are there and for those objects some specified places are there. If no object is placed in their specified places, then that is said to be the de-arrangement. So this is the example I have taken. Now we will have a formula for this one to have the number of de-arrangements, and let us see that now. But before seeing that, if you remember this number of de-arrangements, it is to be remembered because you cannot write all these different arrangements to understand the de-arrangements here. Because it is 3 factorial, 6 arrangements are there, I'm able to write this. If it is 4 factorial, there will be 24. 24, it is difficult to write. And 5 factorial, 120 like that. So, it is better, we will be remembering them in the simplified form. That is, let me write that. Try to remember this, please. Try to remember this so that whenever the question related to this comes, you can straight away write the answer. Let me write that first. That is, if you have 3 objects, in this case, I'm just mentioning it for the better understanding in this way. 3 envelopes plus 3 letters. There will be 2 de-arrangements, please. There will be 2 de-arrangements. 4 envelopes plus 4 letters. There will be 9 de-arrangements. If you write and you will understand that, but we will have a formula for that one. I'll be discussing the formula next. In that formula also you'll be getting the same. Similarly, 5 envelopes, 5 letters, it is 44 de-arrangements. 6 envelopes, 6 letters, it will be 265 de-arrangements. My dear students, try to remember this so that whenever the question related to this comes, you can straight away write the answer. This is what I am asking you to remember. So the number of de-arrangements whenever 3 objects and 3 specified places are there. I just mentioned them as envelopes and letters just for the simple understanding. 3 objects, 3 corresponding places. 4 objects, 4 corresponding places. 5 objects, 5 corresponding places. 6 objects, 6 corresponding places. So the number of de-arrangements whenever 3 objects are there and 3 corresponding places are there, it is 2. Just now, that's what I have shown it here clearly for your better understanding. If it is 4 envelopes, 4 letters, 9 de-arrangements will be there. 5 envelopes, 5 letters, 44 de-arrangements will be there. 6 envelopes, 6 letters, 265 de-arrangements will be there. Up to that, you just remember that. It will be better if you remember that. Okay, so now let us move on to the formula. Let me explain you the formula. That is, you can see the de-arrangements of things here. This is, just see that. if you check it out, any change in the given order of the things is called dearrangement. That's what I said. There are 5 places, 5 objects are there. For each object, there is a specified place. If you are not placing the object in its corresponding place, then it is nothing but the dearrangement. So that's what he's saying. Any change in the given order of the things is called the dearrangement. If n things form an arrangement in a row, the number of ways in which they can be dearranged so that no one of them occupies its original place. No one of them occupies its original place is n factorial into 1 minus 1 by factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus and so on plus minus 1 whole power n into 1 by n factorial. We can remember this easily in the sigma notation so that you can expand it easily. This is sigma n factorial into minus 1 whole power r by r factorial. R runs from 2 to n. R runs from 2 to n. My dear students, please understand that this is 1 minus 1 by factorial anyway that gets cancelled. No need to write that. Just to finish the sequence there, it is shown like that, 1 minus 1 by factorial. 1 minus 1 gets cancelled anyway. It starts with 2 only. That is why I wrote r is equal to 2 here. Now let us expand it to understand. N factorial anyway outside it is written. Outside of sigma it is written. Put r equal to 2 here, minus 1 whole power 2 by 2 factorial. This one, 1 by 2 factorial. Put r equal to 3 here, minus 1 by 3 factorial. Put r equal to 4 plus 1 by 4 factorial. Plus and so on plus. If you write n is equal to, r is equal to n, this is minus 1 whole power n into 1 by n factorial. That's all. So this is the summation that bigger expansion is packed into sigma like that. So it is easy to remember now. N factorial into sigma minus 1 whole power r by r factorial. R runs from 2 to n. If you simplify this only, you will be getting what I said previously. What is that? For n is equal to 3. For n is equal to 3. What should be the answer? For n is equal to 3, you will have r is equal to 2, r is equal to 3. Let me show you that. Let me show you that so that you will better understand this. I am writing that here. If n is equal to 3, 4, 5, 6 and so on. I am writing n equal to 3 first. Let me write n equal to 3. That is 3 factorial sigma minus 1 whole power r by r factorial. R runs from 2 to 3 here because n we have given to be 3 here, n3. Now if you simplify this, my dear students, it is nothing but 3 factorial into, put r equal to 2 here, 1 by 2 factorial. Put r equal to 3 here, minus 1 by 3 factorial. So take LCM, 3 factorial LCM, 3 factorial getting cancelled. Just check it out. What is that you get? 3 factorial by 3 factorial getting cancelled. 3 factorial, here you'll get 3, here minus 1, 3 minus 1, 2. That's what I gave you. 3 envelopes, 3 letters I talked about. That is nothing but 2 only. Similarly, if you put r equal to 4 here, n equal to 4 here, 4 factorial sigma minus 1 whole power r upon r factorial. R runs from 1 to 2 to 4. My dear students, if you expand this, 4 factorial into, put r equal to 2 there, 1 upon 2 factorial, minus 1 upon 3 factorial, plus 1 upon 4 factorial. Let us simplify this now. This is 4 factorial, take LCM, 4 factorial, and 4 factorial by 2 factorial, this is 12, minus 4, this is 1. Just check it out. This 4 factorial getting cancelled. 12 plus 1, 13 minus 4, 9 I gave you if you check it out in the previous screen. In the previous screen, you can Check it out. So every time whenever this type of problems come, you cannot write all this expansion and simplify for the answer. So that is the reason why better remember 3 envelopes, 3 letters, 2 D arrangements, 2 D arrangements, 4 envelopes, 4 letters, 9. That's what I have shown. 5 envelopes, 5 letters, it is 44. 6 envelopes, 6 letters, it is 265. If you apply the formula, you'll get the same.